Good afternoon, students. Today we are going to discuss about the effective length factor for column. The effective length factor for column which we are going to determine for the column member where the column may be braced column or the unbraced column. There are two types of columns in which bracing will be, if the bracing is given to the column, then it will not sway. If the bracing is not available, then the column will get sway. Here you can see a figure which is in 1, 2, 3 floors in which number of columns are there and number of beams are there. So here in the question it is asked to determine the effective length factor for column as for BC for the unbraced column. That means the column will get sway. So the relative stiffness values of I by L, the relative stiffness, what is relative stiffness? It is I by L. It is given in the picture itself, where you can see 4, 4, 2, 3, 5, 3, etc. for all the columns and beams for various members in the frame. This is called frame. So it is indicated in the figure. Take the connection factor as 0.65. The connection factor will be applicable only for the column, not for the beams, because the sway will occur only in the column because of unbracing. Hence, the connection factor should be taken for the columns only. Okay. Now we will see the frame is unbraced, hence it can sway. Now it is asked to find the BC, column BC to be find out the effective length factor of the column. This is the B point and here it is the C. This is B and this is C. So for joint B we have to consider A as well as C. For joint B we have to consider A as well as C. Hence at joint B you can see sum of KC is equal to C into KBA plus KBC, and sum of KB is equal to KBB dash, which is beam, and BB double dash, which is also a beam with in between the joint B. Here you can see B for BC, BA, BB dash and BB double dash. Okay. So based on this you can find, I have already told that this connection factor 0.65 is only applicable for the column only. Hence it is taken as BA and BC is considered, and C is the connection factor which is 0.65, and BA where the relative stiffness is given as BA relative stiffness is given as 3 and BC relative stiffness is given as 3. So 0.65 into 3 plus 3, which is 3.9. Coming to the KB, which is we have to take horizontally, that means the beam B dash and B double dash. Here the B dash is 4 and B double dash is 5. There is no need of connection factor because it is a beam. So 4 plus 5 is equal to 9. So coming to this formula, beta 1 is equal to sum of KC divided by sum of KC plus sum of KB. Sum of KC is nothing but 3.9 and sum of B is 9. So calculating this you can find out the 0.302. How did you find this? How did you find this formula? Here you can see the determination of effective length of columns, which is available in page number 122, highest 800 2007. Here you can see non-sway frame, braced frame. Non-sway frame, that means braced frame. The formula is available as K is equal to 1 plus 0.145 beta 1 plus beta 2 minus 0.65 beta 1 plus beta 2 divided by 2 minus 0.364 beta 1 plus beta 2 minus 0.247 beta 1 beta 2. Again, for sway frames, that is sway frames means unbraced frames. Here the formula is K is equal to 1 minus 0.2 beta 1 plus beta 2, 0.12 beta 1 beta 2 divided by 1 minus 0.8 into beta 1 plus beta 2 plus 0.6 beta 1 into beta 2. Here what is beta 1 and beta 2? Beta 1 and beta 2 is given as beta is equal to sum of K divided by KC plus KB. So whichever joints we are considering, as we have already calculated, it is available in the code book in IS 800 2007 of page number 122. Now we will continue the problem. Here at joint C, we have already discussed in joint B, because in question it is asked to find the B and C, and B we have already calculated. Now at joint C, sum of KC is equal to C into KCB plus KCD. C is the connection factor which is 0.65 and KCB is 3 and KCD is 2. As we have already calculated for B, the same type we have to calculate here also, which is 3.25. Sum of KB is equal to KCC dash, which is the beam horizontal member, CC dash plus CC double dash is equal to 4 plus 5. Here the connection factor is not included because it is a beam. So again the same formula, beta 2 is as per IS 800 2007, sum of KC divided by sum of KC plus sum of KB is equal to 3.25 divided by 3.25 plus 9. So the answer is 0.265. Okay. Coming to the effective length factor of column, as we have discussed earlier in IS 800 2007 page number 122, the same formula is available here for unbraced sway column, which is 1 minus 0.2 into beta 1 plus beta 2 minus 0.12 beta 1 beta 2, 1 minus 0.80 into beta 1 plus beta 2 plus 0.6 into beta 1 plus beta 2 whole power half. That means root of this value. Now we know the values of beta 1 and beta 2 based on the column given as BC in the question. To find the effective length factor, all the values of beta 1 beta 2 is substituted here because only the unknown value is beta 1 beta 2, which we have already calculated based on the recommendation given by IS 800 2007, and all the values of beta 1, which is 0.302, and beta 2, which is 0.265, is substituted here. Based on substitution and calculation, it is found that the effective length factor of column BC is 0.1215. Okay students, I think you have understood how to calculate the effective length factor of a column. Thank you.